Hi, student. Welcome back to the lecture series video. And today we're going to start a new chapter, chapter 8. So basically in the chapter 8, we're going to talk about some, we call this so we'll focus on what we call this the counting rule. So first, let's take a look at why we want to go to chapter 8, okay? So from the previous chapter, chapter 7, right, we talk about a little bit about the probability and then how to find the probability. So like, let's do a kind of a look back of what we learned in the chapter 7. So we talk about the probability. So we start out with the sample space. So the sample space, what we did in the chapter 7 is we list all the possible outcomes, right? So the sample space, we list all the possible outcomes. And then we also define the events, right? So the events here, we say, okay, we can have events A, events B, da, da, da. So events is some specific, so you have like it's a subset of your sample space. Based on some specific rule, right? So we did several very easy example. So for example, the sample space of a toss a die, then you have 1, 2, 3, 4, 5, 6. Then you can define the event A is to get an odd number. Then you can find the probability of the events A. So the way we defined is the probability of the events is how many total number in the sample space and how many total number in that events here, right? So this notation N, that means how many total numbers, right? So that's how do we define the basically how do we define the probability? So if you toss a die, you have a 6 outcome. So your sample space total number is 6. Then if your event A, you define it as an odd number, then event A, you have 3 elements. So the probability is 3 over 6. And we did many those type of examples and your classwork and your My Math Lab. So what is the chapter 8 about? The chapter 8 is kind of related to the chapter 7 right now. And now the ways here right now, we want to talk about some counting rule. So it's some experiment. It's become quite tedious, complex, and we cannot really write it out, all the possible outcomes here, right? So for examples here, we did like in the chapter 7, right? So we say, hey, I'm going to toss 2 dice, right? So you toss 2 dice, we still be able to write it, even will take a while. We have a total 36 outcome, right? So because we have 2 dice, and each dice have 6 faces, so we have 36 outcomes. So we have something like 1, 1, 1, 2, those things, right? So we have a total here the 6, 6, right? So we have a total 36. We still be able to manage that by writing it down. But how about, if you have like toss the 3 dice? Then I think, so the toss 3 dice, then I think it will be pretty difficult, right, to write down the output because total we're going to have like 6 times 6 times 6. we have 216 outcomes. So if you want to write down the one by one, then it probably will take you 15 minutes to write down all this outcome. And some of the experiment we try to do, we can easily end up with thousands or tens thousands outcomes, right? So that's why we cannot write it out every simple space anymore. So that's why we are going to the chapter 8, we're going to talk about the counting rules, okay? So we're going to count total how many if I'm doing this experiment, all right? So in the chapter 8, the section 4.8.1 here. So the first counting rule we're going to focus is the permutations here, all right? So before we start, right? Okay, so we have some notations we need to get familiar with, right? So let's hear, before we start the counting rule, so let's get familiar with let's get familiar with some of the math notations, right? Okay, so let's get familiar with some of the math notation. So the first ones here, the first one we're going to talk about is factorial. So these notations, okay, this factorial, the way we define the factorial is we define it like this. We say it's n factorial, okay? So the n factorial is defined, is just you times it. So it's 1 times 2 times 3 times 4, then all the way times n here, right? So for examples here, okay, so if I say the 5 factorial, what's that mean? That means you times 1 times 2 times 3 times 4 times 5, right? So when you times it, then this one's here will give you 120. So the same way, if I say, you know, if I have 3 factorial, what's that mean? The 3 factorial just be 1 times 2 times 3. All right, so this is 6 here. That's what we have. We call it the factorial. Then we have one very special case you need to remember. Okay, so this is the special case. Is how about if I have a 0 factorial? So remember, the 0 factorial is not equal to 0. So we define the 0 factorial is 1. So be very careful about this special cases, right? So 0 factorial is equal to 1 here, right? So don't forget about that. And then also in your calculator, okay, so in your calculator, you will be also available to use it. Your calculators here, and then in the calculator, they will have a sign is just like the factorial. So if you can find that, so here, so in your calculator, you will have keys here, right? So inside this key is factorial sign. So that's how do you use your calculator, you know, to find it. So this is our first definitions, right? So this is the first definitions about the factorial. And so remember, you know, what is the special case and how did you find this one in your, so how do you find this one in your calculators here, all right? Okay, so now the next things here, with the next notations here, we're going to talk about the next notations. We're going to introduce what is the permutation. Okay, so the permutations here, that is the ones here. The key word to remember is order matter. What do I mean, the order matter? That means the way I take out the things, all right? So the way I take out the things, the order is matter. That means what is the first one I take out? What is the second one I take out? Is matter. If I switch that, they will give me a different outcome. So the permutation is the order is the matters here, right? So that's very important. So that means we know, you know, when you read the problem, so if the order is matter, then we know I'm going to use the permutation. So the notation for the permutations here is just P, N, R, okay? So what is this ones here? So this is the number of permutations of n elements. If you have n elements, okay, then you're taking out, okay, so you're taking out the R every time. So what is the total possible way, right? So it's the total possible way. So that's why this is how we defined, right? The P N R is equal to, so you put it like the n factorial and n minus r factorial. Okay, so I'm going to, so first, you know, let's get familiar with what is the, okay, so let's take a look at the examples here. So get you familiar with what is the permutation means here, okay? Okay, so let's find here. So we say the number of a permutation of letters ABC. That means I do care the order, right? So the permutation, okay, so that means the number of the total way I can rearrange this letter. So see here, so I can put like A, B, C, right? I can put like A, C, B. I can put like the B, A, C. I can put like the B, C, A. I can put like the CAB. I can put like the CBA, right? So total how many ways we have? So the total how many ways? Total we have 6 different ways, right? So we have 6 permutation. Okay, so how do I get the 6? Of course, I wrote it down, right? So ABC, ACB, BAC, BCA. But how about if I have many letters? I cannot write it down. So the reason why this is a 6 total permutation is because I have 3 letters. So I got it is I use n factorial. So this is like a 3 factorial. So this will be just 3 times 2 times, let's do this. So this will just be 1 times 2 times 3. So I know if I rearrange these 3 letters, I'm going to have 6 different ways here, okay? So now let's take a look, how do I use if I take out certain numbers, and then how do I use the, you know, the formulas here. So here is the number of permutations So the number of permutations of letters if you just pick 2 letters. Okay, so let's see how many different ways I can do it out of the 3s, right? So I have 3 letters. I want to take 2, so let's take a look at how many different ways I can find it. Okay, so now take a look at these ones. So you can have like A, B, right? So you can say, okay, I can have A, B, I can have AC, I can have a BC, and I can have a BA, I can have a CA, I can have a CB. So for AB and the BA, we said because permutation is an order matter, so we treat the AB and the BA, they are 2 different outcomes because who is the first, who is the second, they are different, right? So total, we have how many permutations? So total, we have 6 permutations. How do I get a 6? Okay, so now I'm going to use the above formulas, right? So I have a permutation. I have a total 3 letters. So n equal to 3. I'm going to take out the 2 letters. Let's see how many permutations I have. So based on the here, so this is a 3 factorial. Then here, this is 3 minus 2 factorial. So this will be 3 factorial and 1 factorial, right? So 3 factorial is, so the 3 factorial is 6, right? So we have a 6 over 1, so it's 6. So that's how do we get the answer in here is we have 6 different ways. If I have, if I take out the 2 letters from it. Good? Okay. Okay, so now let's take a look at a little bit more complicated ones here. Okay, so let's take a look at next ones here. Okay, so for these examples here, let's take a look. By the way, you guys are still taking a good notes, right? So even we are not in the class, right? Okay, so let's see here. So we say in the 2018 elections, okay, we have a candidate. So we're a candidate and looking, sought for the Republican nominations. So we want to find how many ways could a voter rank their first, second, and the third choices. Okay, so like for these problems here, we said we have 8 candidates, right? So I'm going to vote it. So, hey, this candidate is my first choices, and this candidate my second choice, and this one is my third choice. So that means out of the 8 candidates, I'm going to take out 3. But those 3, the order matter, right? So I pick up the 3s, right? So I pick out the 3. And these 3, the order matter. right? Because why is the order matter? Because the first one is my rank top, the second one I rank the second, the third one I rank the third. So who is the first one I pick does make the difference, because then this one will be my, my top choices, right? So in here I have an n, right? So n is equal to 8. So I have n candidates. All right. So I have n candidates, and then I'm going to pick out the 3, right? And these 3 order matter, right? So I know I need to use the permutation. So I put a PNR here, like the last formula. So we have a P. This is, I'm sorry here. So this is a P. So N is 8. So we put an A, and the R is 3, right? Then we use our formulas here. We say n factorial, so it's a factorial. Then this is a minus 3 factorial. Okay, so then you will have a factorial. So this is the 5 factorials, right? Then the a factorial you can write as 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. And the 5 factorial, you will have 1 times 2 times 3 times 4 times 5, right? That's our factorial definition. And then you will see, oh, that's good. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 can cancel. So my answer will be 6 times 7 times 8. So total will give you 336. That means I'm going to have 336 way to do these permutations here. All right. So now you can write it out. How about, if you say, well, this is going to be pretty difficult to write if you have 20 factorials, right? So here, I'm going to show you how to use the TI-84 calculator to do it, okay? And okay, so here is how we're going to use the TI calculator to figure out the permutations here, right? Okay, so turn your TI calculator on in a clear, empty screens here, because here we are typing we want to find the n to the 3s, right? So the first things you type in, so I'm going to use a different color. So the type in color, I guess I'm going to use the blue. Okay, so you type in 8 because you want to the 8 into 3. Okay, after you type the 8 here, then you hit this button. This button is math. You hit this button. Then after you hit this button on the top, then you go to choose the option PRB. After you choose the PRB, then you move your cursor to the number 2 here. Then they have a PNR. So after that, okay, so you choose this one. So you put the cursor down. Then after you choose this one, then it will back to your screen again. Then you type in 3. Then the last things here you do, you push the enter. Then it should give you the same answer. So it should give you the same answer, is 336. Okay, so if you know how to use this, it will be really help you to simplify is a lot of the calculations here. Okay, and so that's what is the the permutations here. Okay, so now the next things here we're going to talk about is some a special case about the permutations here, right? So let me go here. The next one's here. We're going to talk about this distinguishable. Okay, distinguishables here. So how do we define the distinguishable permutation? So if we say, if the n object, if you have n things here, right? And in a permutation, are not all different, distinguishable. Okay. And so if they are N1 for type 1, N2, we have an N2 object for type 2. And so on. And and so on for R different type. Right? Then the number of distinguishable permutation So yes, so here, this is our formulas here. So it's n factorial, n1 factorial, n2 factorial, to the nr factorial. And you will say, oh my God, this is really looks very complicated, right? So let me give you a simple example. I think then you will understand here. Okay, so examples here. Okay, for the word statistic. Okay, so how many ways we can? So let's see how many ways we can rearrange the letter. Rearrange the letter. Okay, so in here, so let's take a look, right? So for the word statistics, so we have S-T-A-T-I-S-T-I-C-S. So if you count it, so you will say, oh, okay, so total how many word letters we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 letters. So if I rearrange it, well, but I have several very similar letters here, right? So like for examples here, I have S here, I have an S here, I have an S here. So I have 3S. Those 3 S's here are exactly the same. So you arrange it, it doesn't matter, right? So I know I have a 3S here, right? So for the letter S, I have 3. Now, if you take a look, then you will say, how about t? Okay, I have 1, 2, 3. I have 3 t's here also, right? So that means your t, you have 3 t also. Okay, now let's take a look at another one. What is the other one I have a repeat? Oh, I have I. 1, 2. So I have 2 i's here, right? So I is equal to 2. Then for all the others, A is by itself, C is by itself, so it's 1, doesn't matter. So how many total way I can rearrange these ones here? This will be, in fact, so it will be like a 10 factorial, right? That's what is this formula tell you here. So this will be like a 10 factorial. Then I have a 3 factorial, 3 factorial, and the 2 factorial, because those are my repeat. Okay, so now if you calculate this one, so we will get so let's see here. So if the 10 factorial, okay, so we will get this is so 3, and this is a 6 right? So the 3 factorial is 6. So it's 6 times 6 times 2. So we will have 5,400. We have 5,400 ways to rearrange this statistics ways here, right? A while ago, my dog was barking, so I need to pause the video a little bit. Okay, so now let's take a look at a similar example here, all right? Then let's see, can we know how to do that? So this examples here is will show you. I'm going to use the word. Okay, so the word is like this word is Mississippi. Okay, so it's Mississippi. So for the word Mississippi, if I want to rearrange the letter, okay, so how many ways, so how many distinguishable permutation I'm going to have? Okay, so let's write this letter down first. So this is Mississippi, Mississippi. Okay, so first things here, let's try. Okay, so let's try to figure how many n's here we have, how many total numbers. So we have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So total word we have 11. Now let's search for the repeat. Okay, so the first one I find I is repeated. So I have 1, 2, 3, 4, right? So I have 4 repeat I. Then the same way you say, okay, let's see here. Okay, how about the next one? Hey, I find the S is repeated. So it's 1, 2, 3, 4, right? So S I have 4 repeat. Then let's take a look at the next one. What the other one I have a repeat? Oh, P. Okay, so P is good. So it's 1, 2, right? So P, I have 2 repeat. Then the M is by itself. So that's good. So now I can know my total different permutation is 11 factorial, total number of the letters. Then you divide by your repeat, so it will be the 4 factorial, and 4 factorial and 2 factorial, right? So here, if you use your calculator, you will get is 34650. So it's about 35,000 different ways here. Okay? So this is what we call this a permutation. And I'd like to show you one last example, then you will be able to start to, okay, do some of the homework problems and the classwork, right? So this one's here, I'm going to use a different pages here, so I'll be able to put all the questions here. Okay, so we say Kelly and has different book to arrange on a bookshelf. Okay, so those books here, he has 4 books, it's 4 blue books, okay, and the 3 green one, and 2 red, and the 2 red books. Okay, so that's how many books he has to arrange. So it's a 2 red. Okay, so the first, okay, so the part A, they ask you in how many ways the book can be arranged. On the shelf, right? So first thing they say, hey, how many ways the book can be arranged on the shelf, right? Okay, so in here, the total number of the book, total numbers of the books here. So we have 4 blue, 3 green, and 2 red. So total I have 9 books, right? So my answers here, how many books I total to rearrange here? I have 9 factorial. So I have this many way. I have 9 books. We have 362,880 different ways to arrange this book in many different, so you can, some of book you can put on the first and the second. So you have about like more than 500,000 ways to do that. Okay. So now let's take a look. Okay. Okay. So now it's here. So this one's here is the, okay, so how many different way? Okay, so let's see here. So this one's here. The next question is here. They said, if the same color book are identical book, okay, then how many way we can arrange? Then how many way we can arrange here? Arrange those books. Okay, so now in here we say, hey, if the books are blue, all the blue books, they are the same thing. They are, for example, they are the algebra 1 book. They are all the identical book. Then 3 green book is English books. They are all the same English 1 book, right? So for these ones here, we say, okay, this is kind of like just like we did for the non-distinguished book. So we say, okay, so total I have 9 factorial. But I have a repeat book, right? Because 4 blue, they are the same. 3 green, they are the same. And the 2 red, they are the same. So I use my non-distinguishable permutation. So it's 9 divided by 4. So I have 126 way, okay? Okay, so now the next question, that is the interesting one. So our next question is here. The same color book are not identical. Okay, so right now, even we have 4 blue books, but they might be a different books. So here, they are not identical. But we said, but the same color, okay, we can be, so the same color are to be arranged together. Then total, how many ways? Okay, so what is this one to tell you? They said, okay, now I have 4 blue books, right? So this is the book number 1, book number 2, book number 3, book number 4. So it's 4 different blue books. I have 3 green books here. I have a book 1, book 2, and the book 3. 3 different green books and the 2 red ones. So I have a red 1, red 2. Okay, so inside each color, the books are different, all right? And now I'm going to arrange it. So in here, think about this, right? So if I only, but all the blue books, they need to be in one group. All the green books, they need to be one group. So the way, think about it, I said, okay, so here I have 4, right? Factorial. This is how many ways, right? This is how many ways I can arrange. This is arranged for the blue books, right? So I can arrange this many ways. Then the green one, I have 3 books. So I have 3 factorial. So this is the one we call this how many ways I can arrange for the green one, right? So now in here, the red ones here, I have 2 factorial. I can arrange, this is how many different way I can arrange that. And then in here, we say, okay, this is with times, right? So that means it's a 4 factorial times 3 factorial. But this is not the only order. We can put the red group to first or green book to first. So we have 3 colors. So we have totally 3 factorial. We can rearrange those books, right? So total, this is the 1728 way. So this ways here, that means all your blue books is one big chunk, and the green book is one big chunk, and the red book is one big chunk. So like what basically will tell you, your arrangement could be, like on the inside of the green, you have 2 different ways. Inside the green, inside the red, you have 2 different ways, right? Inside the green, you have 6 different ways. So then the total multiplications here. So this is 1728. Okay, so we have a total 1728 different way you can do this permutation. If I care, it's just like the same color. The same color I need to be grouped together, but the same color book doesn't have to be identical. The part B is identical. If the same color is identical, then how many ways? So that will become to the non-distinguishable permutations. Okay. Okay, so this is a section 8.1. We talk about the permutation. Remember, right? The permutation, the key concept here is order does matter. That means I care about the order, right? So AB is different than the BAs here. So, make sure you review the videos and do the classwork. And then the next section we're going to talk about is the combinations here, okay? Nice to talk to you again. So let's, let's quit here and, you'll be able to start to review it. Okay, talk to you next time.